In this video, we will look at the Polymer Lab Part 2, and the part we are going to look at is the household items on the very last page. So the household polymers, and we're going to use the last two pages to figure things out from there. So you can look here, we have, I'm going to grab my little marker here, highlighter. And you have some different things: distilled water bottle, PVC pipe, nonstick pan, Ziploc food storage container. Some of these items are behind me right now. So what we're going to do is match these to recycle code numbers that these things have, come up with the polymer name, and then draw the actual monomer that makes it up. Remember the monomer when we did polyvinyl alcohol was this unit that looked like this with 2 carbons, 4 hydrogens and an oxygen right here, and the monomer combined with another monomer and another and another and another, repeated that to make a polymer. All right, I think I'm going to go with a first example to maybe help you with this. Ultimately, you're getting your data from this from the previous page, and anything with an X on it is not going to be something you use. So there are 6 possible items here, but yet you have 8 to do. And the reason is polyethylene is going to be used. This one right here is going to be used 3 times in 3 various cases. All right, so that's what you're going to be putting together. We'll show you an example, and then I'm going to give you some visuals which you can look at as you're doing this. So if I look at, get back here, we have distilled, I'm sorry, I think I'm going to go to, let's go to the distilled water bottle right at the top. All right, and I'm going to look at some of these things here, and I have a distilled water bottle, and I look at the bottom. So you can look really close and you won't be able to see that, but I'm going to look really close, and I see it has a recycle code of 4. And I'm going to kind of scroll down here and look and say, oh, our recycle code of 4 is polyethylene. And it's low density polyethylene with the recycle code of 4. And then I'm going to look at my structure over on the previous page and find polyethylene, which is right here. And this is a structure. You can either look at it in this form here, where it's double bonded as a monomer. Okay, now what happens, that double bond breaks. So there's 2 carbons, which are black, and 4 hydrogen, which in this case are yellow. And then that double bond breaks, and it could extend out like this. That's just showing what it's going to happen when it forms a polymer. It splits, and then it can connect to another one and another one. And so on. So you can draw that either way, but what's going to happen is, let's go back and maybe show that. And if I go over here and I'm doing this, do a little drawing here, and we're going to say the polymer name is polyethylene. Might just write that in like this. I'm getting that from the previous page. The recycle code that I have is going to be a 4. That's what I read from the bottom of the thing. And then I'm going to draw the monomer. And I think I'm going to go back to drawing this. And I got a carbon connected or bonded or sharing 2 electrons. That's what that stick is, with another carbon. Okay, and then there was an H attached, 1 H there. And an H here. I'm going to take a lot of room here, but it's okay. Another H here. And another H here. Okay, so I could either think of the monomer as being the double bonded part like this, and put another stick in here, Or I could say I'm going to break that double bond and now I can extend the chain and extend the chain. So I think I'll just do it that way. So this is the monomer right here. And I break the chain and I could add another one and another one and another one and another one and get a polymer from there. So that's polyethylene. It's recycle code number 4. This is distilled water bottle. Looks like this. Okay, just going to kind of hit some of these other things. PVC pipe. This will be recycle code number 3. It's not really marked in here. You might see some of the kind of the cheaper shower curtains might have this type of thing too, but that would be a PVC pipe. And then how do you draw that? You can look on the previous page to find that. We'll keep going to the non-stick pan right here. That is this right here. And this is a Teflon pan or tetrafluoro polyethylene. Okay, 4 fluorines. Looks like this. Okay, 4 fluorines attached to this structure right there. Should have probably showed you the PVC pipe that we did previously. Would have a structure like this. One of the H's is replaced by a Cl. That's what the green one's representing right there. That was the PVC pipe. So PVC pipe, polyvinyl chloride, okay, pipe, and then polytetrafluoroethylene would be this one, the nonstick pan with a couple carbons and a bunch of fluorines attached. How about the Ziploc food container? That is going to have a recycle code of a 5. Okay, so I'm looking at the bottom here. There's a recycle code of 5. I don't know if you can see that right up in the corner. You might see that it says PP for polypropylene. And that looks like our original polymer, except it has a carbon with some hydrogens attached. Instead of a hydrogen, carbon with those. Notice in these type of kits, the yellow, instead of yellow ones as being hydrogen, the white ones are hydrogen, the black ones are carbon. But that would be the polypropylene right there. You might see that in some yogurt containers, cottage cheese containers would have a recycle code of 5. We'll keep scrolling down the list here. And I'm going to maybe just do an erase, get rid of this, and come back, grab my spotlight, and we have a styrofoam cup. And this styrofoam cup has a I don't know if you can see that right up there. It's probably upside down. It has a recycle code of 6, okay, in the polystyrene cup right here. And also those clear plastic things you might get a salad in at lunch or something, those would probably be polystyrene as well. And that looks like this. So what happens is you have a structure that looks like this, and then you got this big ring with carbons and hydrogens attached to it. But when you look at your drawing and how that's labeled here, I go to this other page, this is what you're going to actually be seeing for this big ring or benzene ring that we're going to be attaching to this one right here. That's polystyrene. Okay, we'll keep going. Let's see, I think we need to have our milk jug. All right, so our milk jug is right here, milk. Okay, if I look on the bottom, I think I can maybe see an HDPE of 2. You might not be able to get that. It's really a hard backdrop to see that on. Okay, so, but that one has a recycle code of 2. That goes back to polyethylene. So that's a repeat of polyethylene. Okay, it's a second repeat of polyethylene, just like recycle code 1, or I'm sorry, like recycle code 4. Recycle code 2 has that. The Gatorade bottle is also polyethylene like this, but this one has a recycle code of 1. That one's really small in there, so I don't think you can be able to see that, but that's this one right here. So notice a recycle code of 1, really, really hard, firm material. Okay, recycle code of 2, a little bit more firm, but some flex with the milk jug. And then recycle code 4, which is more squeezable, okay? Low density polyethylene right here, all have recycle, all are polyethylene, but they can have different numbers of monomers in the polymer and other things that still give them different characteristics. But they all match polyethylene, but they do have different recycled codes. Okay, finally, the last one is our princess here, but it is the hair, the wig or the doll hair, and that would be polyacrylonitrile. And we got a carbon triple bonded to a nitrogen in this molecule. So again, I think one of the points is just you're going to make these connections between what you see on the previous page and here. I think that should give you enough information to do this. But again, some of the common things we use are polymers based off of relatively simple units that just repeat. And then in the next couple of weeks, when we do covalent bonding, we'll be studying those simple units. All right, good luck as you work through this, and let me know if you have questions. Thank you.